Hi, thank you for attending. It's great to have you with us. My name's Gordon, and during this period when our training centres are closed, due to the government's COVID-19 guidance, we're providing live training sessions to help you progress with your course. So we're all centre assessors, and we're going to be beaming these sessions directly into your homes for you. Please remember to take notes, because this is a lesson, and at the end of the session, there'll be questions, so you can test yourself how much you've learned. Check your guidance, check your learning. So please keep those notes flowing. During these difficult times, there's a high usage of the internet worldwide. There may be a possibility, but the picture might go a bit fuzzy and it drags a little. Don't worry, you'll still be able to hear me. Unfortunately, there's nothing we can do about the internet, but just bear with us and hopefully it won't cause you too many problems. During this lesson, I'll be playing a couple of videos. If you've got some pop-up blockers or ad blockers on your machine, the videos may not play. If the video doesn't play, don't worry, you'll be able to refer back to this video on Student World. All our videos we're creating at the moment are going to be put on Student World, and this one will be up there in probably a couple of days' time. Okay. So today, we're going to be talking all about your 204 practical exam. Now, the 204 is what you'll be doing on week 3 in our centres. It's the only practical assessment you do on your level 2 course. You do 4 online assessments, but this is the only practical assessment. Now, in the previous 2 weeks, you'll be doing lots of practical work in the workshops alongside your assessor. He'll be preparing you for the assessment. And I just want to talk through this assessment of what you're actually going to be doing, what materials you're actually doing, and how you actually get assessed. Okay, so let's start off with a PowerPoint. And like I said, don't forget, keep those notes flowing. So here we go. First of all, with a little presentation, show you exactly what's going to be happening in your 204 assessment. So first of all, what is your 204 assessment? It's, as I said earlier, it's your practical assessment for your level 2. It actually takes, according to City and Guilds, it takes 8 hours to do your practical assessment, and you've got 2 further hours to do your testing. Now, in reality, because of the days, how long we actually are in the centres, we spread that over 2 days. Otherwise, you'd have a potentially an 8-hour, very, very intensive day. So we spread it over 2 days, which sounds a long time, but believe me, when you're in there, it does get quite intense. We're trying to simulate how you'd actually react on site. Okay, put you under a little bit of pressure, because that's what you need to do. On site, you can't just take your time. Most of the time, especially if you're working for yourself, you've got a price generally, and you want to get that job done as quickly as possible and move on to the next job to make more money. Okay, so you need a little bit of pressure. So you'll be installing wiring systems. And what we talk about wiring systems is lighting, power, radial circuits. Okay, now you've got to do it to a drawing. I'll show you the drawing in a few minutes, and it's got to be exact to that drawing, because when you're in the real world, you get given drawings, and you can't just make your own circuits up and decide I'll put a socket there, a light there, and use this cable or that size cable. Somebody's actually put a lot of effort into designing that circuit, that installation, and you've got to adhere to that. You've got to work within health and safety guidance. When you're on site, particularly big sites, there are health and safety inspectors walking around constantly giving you potentially your red and yellow cards if you do something wrong, if you're not wearing your PPE. And what we're talking about PPE, your glasses, your gloves, your high-vis jacket, and most importantly, if I can fit this on, your helmet. Okay, you've got to wear your PPE. You've heard about this in the news so often recently. It's very, very important. So if you're not wearing your PPE in the workshop, we'll stop the assessment, because you're putting yourself at risk. You're putting your assessor at risk and potentially other people working around you. Dimensions on the drawing, you'll see in a minute. All drawings have a dimension. You've got to stick to those. You can't decide, and let's just show an example. For argument's sake, here's a little socket. If you've got to install this socket, okay, and you decide, you know what, I'm going to stick it there. But in reality, the drawing says it needs to be there. The reason for that is, what you don't particularly know, there might be a pipe here. You put your socket in, and suddenly that pipe's in the way, okay? You can't do that. If it says 400 millimeters from a wall, it's got to be 400 millimeters. You can't decide to do it 420. And again, if you don't do that, you'll fail the assessment. And finally, all the cables must be terminated and installed in accordance with BS 7671. You're probably aware that's the regulation book. Okay, there are very specific regulations in there telling you how to install cables. If you don't do them, you're potentially creating a fault and a fire risk and electric shocks. All joints must be mechanically sound. What we mean by that is, again, if we take this conduit, if we're going to put a box on that, that has to be really secure. It's got to be secure against the wall as well. You can't have something flopping around on a wall. It's got to be secure. Once your assessor has checked that all your equipment is secure, the wiring is up to standard, he then asks you to do some testing. Now, a lot of people get really stressed and worried about testing, but you're going to just do what we call the dead tests: continuity conductors, insulation resistance, and polarity. Now, when it comes to doing your 204 assessment, you shouldn't worry about this, because the previous week, week 2, you'll be doing your 2392. This is your level 2 test and inspection exam. So in order to pass that, you should be quite competent in testing. So the very fact that this comes after your 2392, this should be easy. Now, as I said earlier, you probably remember, you get 2 hours to do your testing. In reality, the size of this circuit, if you're reasonably competent, you probably could do that in about 30 minutes, actually. So it gives you a little bit more time on the installation side. So another further thing you do, once you've done your testing, and again, you'll find this in your 2392, you'll do a schedule of test results. And I'll show you a copy and an example later on one of the slides. It's basically, all that is just you recording what results you've found. And the final thing is producing a materials list. This is to get you into the habit of looking at a job and working out what you actually need. There's nothing more frustrating than you going to put some lights in for somebody in somebody's house, and in your head you suddenly think, I want a light, I want a switch, I want a box, but you forget silly little things like the raw plugs, the screws to hold it all together, then maybe the green insulation sleeving to go on your CPC. So getting into the habit of writing a materials list is really good practice, and that's part of your 204 assessment. And the final bit on there, before we start going through the materials, is failure to do any of those stages will result in termination of assessment, because we can't have you doing a practical assessment in an unsafe way. Just like if you were on site, going back to the red and yellow car scenario, you'll be taken off site for your safety and for others. So the installation, what you'll be doing, you'll be in a ring circuit using singles cables. You'll be doing a radial circuit to an outdoor socket. And if you don't know what an outdoor socket is, it's one of these. That'll be attached to the wall, and you plug your socket into there, or you plug into there. And also we're doing a lighting circuit. And again, it's going to be doing a two-way lighting circuit. And if you're not familiar with that phrase, a two-way lighting circuit is, if you imagine on a hallway or on a staircase, you have a switch at the bottom, a switch at the top. So any one of those positions, you can turn the light on and off. That's what we call a two-way lighting circuit. And again, you'll be doing those singles in plastic conduit. And then finally, we've got bonding cables. We have 2 copper pipes, which is to simulate your gas and your water. If you look in your house or flat, wherever you live, under the sink or where the gas meter is, you'll see a bit of green cable, quite a thick green cable called bonding cable like this. And it's attached onto that. And that's to sort the earthing out, the equipotential bonding, which we're going to be doing a whole another lesson on earthing. Okay, so let's move on to some of the materials. But before we do that, the practical layout, there's your diagram. That's what you'll be building. Looks a bit frightening, and it is, and it's meant to be. As I said earlier, you need a little bit of stress, you need a little bit of pressure, but after you've done all the practical assessments in the centres prior to this, it won't be an issue. So the first material we'll be using is metal conduit, and that's what we've got here. Basics, it's a tube, it's a pipe. Okay, You can hear, but it's actually solid metal, really difficult. You cannot bend that by your hand. You need, just on the picture on the screen, what we call a pipe bender. Okay, you'll be shown how to use one. I haven't got one here, unfortunately, because I'm not in a center, but you're going to be doing bends, you're going to be putting threads on it, and you're going to be cutting it to a certain size. Two common sizes for this is 20 mil, which is this one. That means a 20 mil diameter at the top there, or 25 mil. It's either made out of galvanized steel, which is this, like a silver coating, designed to be used outside, or a black enamel steel, which is basically similar to this, but painted black. Now, the black enamel steel isn't designed to be used outside because it rusts. Okay, so only the galvanized steel is used outside. It's designed for mechanical protection because what we're using there, we use singles cables like this. Now, singles cables has only got one layer of insulation on it. Now, you would never just clip this to a wall anywhere because it's just, as it's got one layer of insulation, it's very fragile. So we put the singles cables into the metal conduit for extra mechanical protection. Plastic conduit is exactly the same as the metal conduit, but it's made of plastic. Similar sizes. You've got the 20 mil and the 25 mil, but it doesn't really offer a lot of mechanical protection. You see on this, I can actually bend this. You know, that's not because I've had my spinach this morning, because it's quite fragile. If you hit this with a hammer, it'll just snap, particularly if it's cold. It gets very, very brittle. Okay, what we do with this, we bend it with a bending spring. And I've got another session, which is in a couple of weeks' time, which is all about metal and plastic conduits, how to bend them, and actually demonstrate how to bend this. Similar sort of thing. Inside that, we would actually put the singles cables to offer that mechanical protection. This you would use where you're not going to get a lot of heavy duty. Somewhere, I wouldn't necessarily use it domestically, but you might put it in your shed, you might put it in your garage. You certainly wouldn't be putting it anywhere where there's maybe a forklift truck, because if it hits that, it'll just shatter. Metal trunking. You'll be using this size metal trunking, and this is what is a 50 mil by 50 mil metal trunking. You'll be cutting it to the relevant size. You'll be drilling holes in it, and you'll be also making a lid with a nice end cap on the end. Okay, this is to install again your singles cables where your metal trunking and metal conduit will be attached to. It comes in lots of different sizes. It also comes in plastic sizes, which you'd use in a domestic environment. This one, just like the metal conduit, you'd use it where you need a bit more robust mechanical protection. Metal tray, you'll be making a right angle bend out of metal tray. This is what we call metal tray work. Okay, it'll be coming in a flat piece like this, and then you'll be cutting various cuts in there to give it this lovely right angled, which will be secured with bolts. Now, metal trunking is used for housing cables such as steel wire armored. It can be attached directly to the wall, which you'll be doing, or dangling from a ceiling through threaded rods. And again, it comes in various sizes. The one you're using, as it says on the screen, which is a 100mm light tray, so it's quite light duty. Steel wire armored is this cable. As you can see, inside the cable at the top, you've got these steel braiding, this steel wire, which gives it some strength. It's designed to be used in industrial areas. It's also designed, it can be buried underground. But as it says on the second line on the screen, if you bury it in the ground, you've got to do at least 600mm of depth above it. That's generally bigger than an average shovel or spade. So if you did dig into the ground, you're not going to damage this. Comes in various sizes. This one's a 3-core, 2mm, 2.5mm. And again, it's designed in the main intake of your house will have one of these coming into it. Okay. Singles cables, just touched on. is what we've got here. It's literally a cable which has got one layer of insulation on it. Now, bring that right up to the screen here. You can see this is stranded. It's got 7 strands. This allows the cable to be much more flexible when it's going around the bends inside the conduits. If you had a solid cable, it'd be very difficult to get these around a bend. What I mean by solid is if you look at your standard domestic cable, which you have here, it's only got the one strand or one solid piece of cable. So that allows singles to be a lot more flexible to go around. And as it says, it comes in sizes from 1mm to 95mm. There's your materials list. It's got everything on there, from the cables to the conduit to the trunking to the actual screws that hold it all together. It's very important you make sure you get everything on that list, because there's nothing more frustrating. You're doing a job and you've got one tiny little piece missing out the whole puzzle and you can't finish that job. You've got to wait until the next day, especially if later when the wholesaler or Wix or wherever you buy your equipment is closed. It's very frustrating. You have to go back to that job because at that point you're losing money. That's what you don't want to do. And then the final slide, that's what we call the schedule of test results. And as I said earlier, it's just a record of what circuits you've put in and what the results of the 3 tests you're going to be doing: continuity, insulation, and polarity. There's a few extra columns in there describing the size of MCB, etc. But in essence, that's what we're going to be doing. And that's your 204 assessment in a nutshell. Okay, I'm going to show you a little video now, and this is basically design quality of work which we don't want to see. Some really poor examples of work which has been done on an installation. So hopefully you've taken notes, because after that I've got your little quiz for you of 12 questions all about your 204 assessment. So let's sign that video, and like I said, this is what we don't want to see when we come and see and check your 204 assessment. So watch.
Okay, as we're here for the electrics, just going to quickly show you, we've got a switchboard over here. This job here, someone's come along, it's been a fault, and he has rewired, because he couldn't find the fault, so he's rewired everything. If you look very carefully there, you can actually see that the cable's a bit burnt at the top of the main switch. It's got an RCD on its own, protecting the oven, a 40 amp RCD, which is made for a 6mm cable, protecting the 32 amp oven on a 32 amp wire. We've got a 63 amp main switch, protecting a 6mm cable, which is good for 40 amps. And then we've got a copper buzz bar just up there in the board. I don't really want to get my fingers too close because I haven't turned off the power yet. I just walked in here. But that there, you can see just over there, that piece of copper, very, very, very close to the neutral, uninsulated. That's really dangerous. People don't like that. No, this is just indicative of what's going on here. So basically, this guy's had his renovation been done, and they've rewired the whole joint, and this is the finished product. I think it was at this stage that the client got a bit jacket and sent him on his way. Here's our PowerPoints in the cupboard. Here is our PowerPoint behind the sink. Not sure what's going on there. Here's our switch for the cooker pieces. This is our wiring to the cooker. Here we go. There's our wiring. It's got a chase. The name grinder right next to a fire hydrant. I think the fire crew hasn't been out here yet. I'm surprised the fire crew hasn't been out here. And this is a power running to a PowerPoint. Not sure how someone thought they were getting away with this. And here we're going to...
As you can appreciate, let's bring you back up to the AV. As you can appreciate, that installation would have failed any inspection. Any of those failures in terms of the connections, the type of wiring, how it's put together, your 204 assessment would have been stopped a long time before that, because that is a really dangerous health and safety issue for you and your assessor. Okay, right, let's get on with those questions. And let's see how much you've been taking note. Okay, we're going to go through them. You're going to get instant feedback on how well you've done, and then we'll quickly go through the answers to them, which will be highlighted in green. What is a common size of plastic conduit for question 1? Question 2. Metal conduit can be made of what type of steel? Question 3. SWA stands for? Question number 4. Socket outlets are commonly wired in what size cable? Question number 5. Lighting points are commonly wired in what size cable? Halfway through. Number 6. An extra socket outlet, not part of the ring circuit, but connected to the ring circuit, is described as a? Question number 7. What does PVC stand for, as in PVC cable? Question number 8. What would you use to bend a plastic conduit? Question 9. Where would you use black enameled conduit? Number 10. Why are singles cables stranded? Remember I showed you the 7 strands. Why do we use them? Number 11. What's the minimum depth when we bury a SWA cable? Almost gave the answer away to a previous question there. An SWA cable. And finally, what type of lighting circuit are you going to build? Okay, well done. I said any second now you're going to get your answers fed back to you. Hopefully you've got all of them right. So let's just quickly go through those answers so you can make a note. Common size of plastic conduit is 20 mil. The other one was 25, if you remember. So 1B. Question 2. What type of steel can a conduit be made of? And it's question B again, or answer B, which is galvanized. Question number 3. Steel wire armored is what SWA stands for. So the answer would be D. Again, for question 4, the answer is D at 2.5 millimeter. Socket outlets are commonly wired in that size. Question number 5, the answer is A, 1.5 millimeter for the lighting points. Question number 6, the answer is C, it's a spur. Question number 7, PVC stands for polyvinyl chloride, so the answer would be D. Question 8, the answer would be A. We use a bending spring to bend plastic conduit, which I said will be another video coming up all about plastic and metal conduit. Question number 9, use black enameled, or BE as it's shortened to, in an indoors environment. So it'd be answer B. Question 10, we use singles because it makes them more flexible to go into the conduit around the bends. So the answer would be C for question 10. Question 11, 600 millimeters is the minimum depth. Remember we talked about how large a spade is going into the ground. So question 11, The answer would be C, 600 millimeters. And finally, question 12, a two-way lighting circuit is what you'll be building. So the answer to question 12 would be B. So I hope you got all those right. If not, I hope you got lots of them right. And the ones you didn't know, make a note of, because they'll be very useful when you come into the centres on week 2 and especially week 3 when you do your 204 installation. I hope you've learned something from today, and I hope that's giving you a bit of confidence, because a lot of people starting these courses have a little bit worried about the practical side. But like I said, when you break it down, it's not that tricky. Meant to be a little bit of pressure, as I mentioned, but very passable. Okay, I hope you've enjoyed that. So thanks for attending. It's really great to have you with us. There's more sessions coming up, so please look on Student World and book yourself in the ones which you think are applicable to you. So please stay indoors, stay well, stay safe, and see you on the next one.